Hello students and welcome to today's class. In the series of lectures on the evolution of humans on this planet, I will be talking about today about Homo erectus and the transition to Homo sapiens. And essentially we will be looking at the evolution of the modern Homo sapiens on this planet. There are different objectives of the study, and these objectives are to know about the complex evolutionary history, the evolution from Homo erectus who were Homo sapiens, the contemporary of Homo sapiens, and then we will be also talking about the competing hypotheses of hominids. Scientists have recently proposed that the universe as we know it started some 13.8 billion years ago. Around 4.5 billion years ago, the Sun and Earth formed, and a billion years later, the first life forms emerged from the oceans. The survival and reproduction of all living things is due to their unique set of adaptive characteristics that evolved over time. Slow and rapid environmental changes caused by geological processes led to the emergence of novel kinds of life. Environmental changes throughout millions of years favored the emergence of plants, fish, amphibians, reptiles, and ultimately the mammals. Fossil records show that primates first appeared around 67 million years ago. Larger brains, stereoscopic vision, grasping hands and feet, and more extended gestation periods, maternal dependency, a sophisticated social life, and increased learning and memory are just a few of the human-like traits shared by the wide variety of mammals in this category. Lemurs, tarsiers, and lorises are a few examples of promisians who share a common lineage with early primates. Anthropoid primates, which include humans, apes, and monkeys, they evolved later than other primate groups, but shared a common ancestry and essential commonalities. Primate species share the same evolutionary origin, which accounts for the striking similarities. One of the most common misconceptions about our species' historical development is the idea that we evolved directly from apes like the chimpanzee and the gorilla. Historically, scientists have used physical features representing shared evolutionary history of classifying monkeys into, for example, families, into genera and species. Over the past decade, the deciphering of genetic codes has allowed scientists to discover the unique genetic linkages across living ape species. The results suggest that humans and the African apes are more closely related to one another than either of these groups is to the orangutans. Similarities in their evolutionary histories have led to the classification of humans, chimpanzees, gorillas, and orangutans into the same family, Hominidae. Sometimes just orangutans are mentioned while talking about the Ponginae subfamily, which also includes gorillas and chimpanzees, but not humans. Because of their unique characteristics, humans and their ancestors, they are placed in a separate group, which is known as the hominini or the hominin. Anthropologists have been putting theories regarding hominid evolution to the test for the past 150 years. Hominins, including contemporary humans, they share many anatomical features with other primates, including teeth, jaws, and the brain. Of all their unique characteristics, however, the ability to walk upright on two legs, which is often termed as bipedalism, is one of the most striking features. The genus Homo, which includes the modern humans even, is characterized among the hominini by a general rise in cranial capacity, which is related to the thinking ability of the past humans. The fossil record reveals that we developed from a small brained bipedal primate during the last 10 million years. The search for the missing link between humans and other primates like chimpanzees has been misunderstood by some anthropologists and even archaeologists, because it implies that evolution follows a linear path with clearly marked nodes demonstrating shared ancestors and linkages. The term missing link has generated controversy among paleoanthropologists. Following this line of thinking, there must have been only one evolutionary step between apes and humans. The fossil record demonstrates that evolution is much messier than commonly believed, with distinct lines developing at different rates, new traits appearing several times independently, and populations splitting and interbreeding across long periods of time and across multiple continents. Instead of a neatly ordered tree of life revealing common ancestors, the fossil record looks more like a thorn bush with branches that cross and overlap one another. Simply said, there was never just one missing link between apes and humans. Fossils have been discovered that seem to hint at creatures that share characteristics with both apes and humans. The fossil evidence discovered in Chad, which has been dated to around 6 to 7 million years ago, is fragmentary, nevertheless interesting for understanding the origins of life on Earth. This specimen belongs to the species Sahelanthropus shadensis. The fossils indicate that these people had very tiny brains, small canine teeth like humans, and a prominent forehead, ridge similar to apes. There is an entire, if abnormally shaped skull present in this specimen. The lack of a pelvis and a complete pelvic girdle makes it hard to identify full bipedalism clearly, but the position of the spinal cord in respect to the cranium suggests an upright bipedal species. Two more exciting new fossil discoveries of ancient animals from Kenya were announced in 2001. Aurorin tugenensis, which is also known as the Millennium Man, is a famous skeleton whose postcranial and dental remains have been dated to roughly 6 million years ago. Some postcranial evidence suggests that these ancient hominins were already bipedal. When compared to the later discovered Australopithecus, the discovery of such ancient remains of incredibly primate species is very interesting, since it may indicate a shared ancestry with the future evolution of our genus, which is known as Homo. The discovery of 110 fossilized remains of a female hominid in Ethiopia, which paleoanthropologist Tim White and his colleagues dated to 4.4 million years ago, sheds new light on the theory of early human evolution. These fossils are sufficiently different from those of early Australopithecines that a new genus, Ardipithecus ramidus, had to be developed to accommodate them. Ardi was short. He stood at around 4 feet, but he was yet very stocky. When compared to later species, Ardi's hands and fingers look more like those of gorillas. In addition, she had an ape-like toe, complete with a grabbing claw, which she used to help her climb trees. However, postcranial features like the pelvis provide clues pointing to bipedalism. This time around, bipedalism stands out as the most distinctive trait of hominins compared to other primates. These fossils are not yet certain to represent the earliest true hominins, which is additional research is needed. Homo erectus. Now talking about this species, multiple sites outside Africa have yielded early hominin fossils, suggesting that these humans spread out from Africa more quickly than previously thought. However, most fossil evidence is associated with Homo erectus and has been discovered in China, Java, which is a major island in Indonesia, then the Middle East, Europe, and even Africa. These objects were left behind anywhere from 1800 to 250,000 years ago. Early Africans were home to Homo erectus, Homo habilis, and Homo rudolfensis, among other hominins. One of the most remarkable finds is that of the Turkana infant, a complete skeleton found in a cave at the Neriakotom site in Kenya's Lake Turkana region. The bones of a kid of 8 years old, which is remarkably intact and stands at roughly 5 feet tall, are a valid size comparison to the current people. The Turkana child is fully human below the neck, as evidenced by his skeleton. The head size is compatible with a brain volume of about 900 cc for Homo erectus. Homo erectus fossils represent a major new development in the evolution of hominins, especially in terms of brain size. Cranial capacity ranged from 895 to 1040 cc in some Homo erectus individuals, making them comparable to present human skull capabilities. These results suggest that the neocortex contributed significantly to the overall enlargement of the brain. Homo erectus people were different from modern humans because of their broad muscular jawline and large teeth instead of their rounded forehead. Compared to earlier Homo species like Homo habilis, this one had smaller jaws and teeth. These species' bones below the neck resemble ours pretty closely, but their bulky bone structure conceals a considerably more potent muscle system. At this point in hominid evolution, the physical characteristics of Homo erectus seem to have changed very little. Now coming to another species of the humans, which is known as the Homo sapiens, one of the very important developments in the evolutionary history of humans. The fossil record shows that over time, Homo erectus evolved into Homo sapiens, a more human-like species. To those versed in paleoanthropology, the term archaic Homo sapiens denotes a generic taxonomic category that encompasses a wide variety of transitional creatures, sharing traits of both Homo erectus and modern humans. All around the world, from Europe to Africa to Asia to the Middle East, fossils of these species they have been unearthed from many archaeological sites. The oldest known transitional form, Homo heidelbergensis, was discovered in Heidelberg in Germany between 7 lakh and 2 lakh years ago. However, it may be related to another find whose name is Homo antecessor, which was located in Spain and dated to around 8 lakh years ago. The ancestors of both modern humans and the extinct Homo neanderthalensis may lie with these morphologically nebulous individuals. The Homo neanderthalensis population lived in Europe between 4,30,000 years and 24,000 years ago and is commonly referred to as the Neanderthal. Due to a shortage of evidence, some paleoanthropologists have placed this species into our own by labeling it the Homo sapiens neanderthalensis. All archaic Homo sapiens shared a few essential physical characteristics, even though There were regional variances. They were probably no more than 5 feet and 6 inches tall, but they were surprisingly robust for their small stature, wider and more robust than those of the modern humans. The brow ridges were more pronounced, the jaw was wider, and the teeth were more prominent. The Neanderthal, who stands out physically from other archaic Homo sapiens, has become the prototypical caveman in media depictions. Inaccurate as they are, these representations of primitive savage animals must be discarded. Skull volumes between 1200 and 2000 cc suggests that the Neanderthal could have had a brain comparable to or larger than that of modern humans. In addition, recent studies of Neanderthal skulls indicate that their brain anatomy was strikingly similar to that of the modern humans. Analysis of DNA extracted from Neanderthal remains may shed light on the evolutionary history of this mysterious species. The genetic data implies that the two populations interbred approximately around 50,000 years ago, even though estimates of when the Neanderthals and modern humans separated range from 5 lakh years ago. Genetic analysis of modern human populations has revealed that those of us who aren't African carry between 1.5 and 4% Neanderthal DNA. Neanderthal genes in modern people may have warded against local infections and diseases in the past, yet they could now have an impact on anything from, let us say, allergy sensitivity to the risk of developing depression even. The discovery of the Denisovanes or the Denisova hominins through fossil and archaeological investigation has tremendously enhanced our understanding of these prehistoric human groups. Denisovans were a subspecies of Homo sapiens that lived at the same time as both modern humans and Neanderthals. These human remains were discovered in Denisova cave in the Russian region of Siberia. Archaeological evidence indicates that people have been residing in this area for at least the past 1,25,000 years. Archaeological evidence suggests that modern humans and Neanderthals they inhabited the area under question. Genetic proof that the Denisovans bred with Neanderthals and anatomically modern humans is provided by bones excavated at the site dating to around 30,000 and 48,000 years ago. Genomic evidence suggests further investigation into the possibility of hybridization with a third human lineage separated from both Neanderthals and modern humans. A Denisovan jawbone dating back 160 years was discovered in a cave in Gansu, which is located in the modern day China. This adds more evidence to the theory that this hominin lived in Asia. In light of these discoveries, it is clear that paleoanthropologists have a lot of work to do before they can provide satisfactory answers to many questions about human relationships throughout their history. Now, we will be talking about the Middle Paleolithic technology and the rise of the Neanderthals, which is a very important species in the evolutionary track of the modern humans. Early European archaic Homo sapiens who had moved to Europe from Africa used Acheulean stone tools. After the rock shelter near Le Moustier, which is located in France, was discovered, where it was first even documented also, the Mousterian tradition is another name for the stone tool industry associated with these Neanderthal tribals. Mousterian style technology is typically placed in the Middle Paleolithic, also known as the Middle Stone Age. Middle Paleolithic manufacturing can be recognized by how drastically different it is from the earlier techniques used by the humans in the lower Paleolithic times. For example, Mousterian tools can be used for cutting, leather working, piercing, food preparation, woodworking, hunting, and weapon manufacturing. Additionally, if Neanderthals hadn't perfected the craft of weaving clothing, they would have had a very difficult time surviving in Europe's hostile climate. Archaeologists have discovered caves and even rock shelters that were heavily occupied, as well as open air sites that may have been summer camps for those Neanderthals. Excavations have uncovered charred bones and charcoal deposits, suggesting that Neanderthals, like earlier Homo erectus, used fire for more than just keeping warm. There is evidence of cannibalism also in the form of cut marks on the skeletal remains which were discovered at the Neanderthal sites in Spain, France, and even in Belgium. Now, moving to another aspect, which is the transformation of these Neanderthals into the modern humans. Many paleoanthropologists agree that Homo erectus was the ancestor of modern humans, although they disagree on when and where this transition took place. A lack of information and a stress on the uniqueness of such discovery characterized early explanations. Scholars have put out a variety of models and ideas in recent years which shaped the actual theoretical background related to the evolution of the humans. Modern humans, according to the scientific community, spread out of Africa. Nonetheless, numerous competing hypotheses are still being investigated. We already knew that Homo erectus, among extant hominins, has the biggest known distributional range. Homo erectus, Homo sapiens sapiens, and contemporary Homo sapiens are said to have developed separately in Asia, in Africa, and even in Europe, according to the multi-regional evolutionary hypothesis. Many anthropologists, beginning in the 1940s and continuing until the 1980s, they believed that a model first proposed in the 1940s provided the best explanation for how modern humans evolved. Differences in appearance between modern day humans can be traced back to when Homo erectus lived in different parts of the world and developed unique characteristics in response to the selective pressures and genetic differences of their environments. Gene flow, the free exchange of genetic material between different populations, impeded the formation of new species. Even if later generations of the species preserved some of their localized characteristics, the emergence of Homo sapiens was a global phenomenon. One of the competing basic paradigms for explaining contemporary human evolution is the single source, or what we also call the replacement model. This idea proposes that Homo sapiens first appeared in one geographical region before dispersing or diffusing to the rest of the world. According to the replacement theory, Homo sapiens coexisted with and ultimately displaced Homo erectus. So, although they both lived on Earth, modern and ancient species represent very different evolutionary paths. All modern day Homo sapiens tribes, according to the replacement theory, share some common ancestors. The out of Africa hypothesis, this postulates that Homo heidelbergensis some 4 lakh years ago gave rise to both modern Homo sapiens and even Homo neanderthalensis in Africa and in Europe respectively. But Homo sapiens prevailed in the end, and the Neanderthals obviously they died out. Scientists believe that the original home of all hominins, that is Africa, may provide fossil evidence that confirms the substitution theory. As we saw before, remains of anatomically modern Homo sapiens have been discovered in Morocco and dated to as early as 3,20,000 years ago. There is a possibility that the fossils found in Africa are the earliest examples of modern humans. To paraphrase, for example, the replacement theory, we can say that after emerging in Africa, early Homo sapiens, they migrated to other locations. They displaced older hominin populations that had arrived there hundreds and thousands of years earlier. Neither of these two central theories can adequately account for the complex processes that led to the emergence of the modern humans. There have been many recent attempts to reconcile the gaps between the multi-regional and the replacement models of human evolution or origin. The first human tribes very likely had a wide diversity of physical appearances in addition to behavioral, social and linguistic variations. Even if early human migrations did occur, it is unlikely that entire population is moved in the same direction, either out of Africa or elsewhere. Migrations via many different, for example, routes and the repopulation of formerly populated areas are also very plausible, as is gene flow, which is the exchange of genetic material across populations. Complexity theory not only helps us to understand from where we modern humans came, but it also tells us how we became the melting pots of cultures as we are today. New genetic evidence from Neanderthal and Denisovan fossils lends credence to the hybridization and assimilation hypothesis, which posits that Homo sapiens absorbed features from extinct human groups. Hybridization and assimilation suggests that modern Homo sapiens first emerged in Africa some 1 lakh years ago and then spread to other regions of the world. In the end, anatomically modern humans supplanted the older archaic groups because of hybridization between the two. Multiple fossil hominin species have been unearthed in different locations, including the Near East, Europe and even East Asia. It is clear from these discussions that there is more gene flow than what the replacement model predicts. We might be getting closer to a model that captures the complexities and sluggish dynamics at play here. This is all what we have to study in the topic related to the evolutionary path of the Homo erectus. Thank you so much. Hope you have enjoyed the session. This is all what we have to study about the development or the evolution of the Homo erectus species in the evolutionary theory. Hope you have enjoyed the session. Thank you so much.